this lesson, we're going to talk about logarithms, and you need to remember two main things. The first thing is that the log base b of y is equal to x, and the inverse of that, the flip side of that, is b to the x is equal y. So I'm going to go ahead and leave this up here. It's probably the most important thing for the entire lesson. Now, the reason we have logarithms in the first place is because when we have an exponent and x is stuck up in the exponent, like it is right here, the only way we can solve for x is by using logarithms to get it out of the exponent, because we take it from this form to this form, and now we can solve for x. So let me show you what I'm talking about with an example here. My first example is log base 2, 8 equals 3. And we're going to flip back and forth here. And we're going to write 2 to the third power equals 8. So the base goes right here. This part from the other side goes to the exponent. And the 8 gets moved to the other side. So log base 2 of 8 equals 3 is the same as saying 2 to the third power equals 8. Let's say we want to go the other direction. So let's say we have 12 to the first power equals 12, which is true. We want to turn this into a logarithm. So we're going to write log base 12, that goes right there, of 12 equals 1. So you need to be able to flip back and forth between these two systems. The problem with logarithms is that we've actually reached the limits of what the graphing calculator can do for us. The graphing calculator has a button that says log, which is right here, down here on the bottom left area. But that only works when we're dealing with log with a base of 10. It can't do anything else. The graphing calculator only does log with a base of 10. If you see anything else, like log base 2, log base 8, it can't evaluate these. So you're really not going to be able to rely on your calculator here. The calculator only understands log base 10. It understands this. Log base 10 of y equals x, and it understands the inverse, 10 to the x equals y. But it can't do anything else. There's one more type of logarithm that you need to know, and that is called a natural logarithm. And a natural logarithm is ln, so L natural, which is the natural log x, the natural log of y equals x. Now, natural log has a special base. It only has one base, and that's base e. This log has a base that's a number, but natural log has a base of e. So the flipped form of that is e to the x equals y. It only has a base of e, so it becomes e to the power of x, move the y over here, e to the x equals y. So what do you do if you can't use a calculator? What if it tells you it wants to know the log base 7 of 49, and it says, what does it equal? Well, you need to know it's 7 to some number, question mark, equals 49, because that's how we rewrite it. We move the b right here, this moves here, 49 moves over to the other side of the equation. So 7 to what power equals 49? That's 7 squared equals 49. That's how you do this without a calculator. However, there is a way to cheat and use the calculator. We call this the change of base equation. And I'll show you what to do. If it says find log base 749 without a calculator, you say, I'm going to use a calculator, and I'm going to rewrite it like this. You write log 49 divided by log 7. So of course, using the calculator, that's log base 10, because that's the only type the calculator understands, but it doesn't matter because it actually works here. So we just type this into the calculator. We get log 49 divided by log 7, and it tells us it's 2. So you can do it without a calculator and with a calculator. One more example. So let's say we have log base 1/2, 8, and it wants to know what that equals. Well, we're going to rewrite this as 1/2 to some power equals 8, and you have to know 1/2 to what power equals 8. The only way to get a fraction into a whole number is to use a negative exponent. So we have 1/2 to the negative 3 equals 8. That flips it. 2 to the 3 equals 8. Now if we want to do that with a calculator, it's log base 1/2 equals 8. We're going to rewrite this as log 8 divided by log 1/2. Let's do that really fast. Log 8 divided by log 1/2. And it's going to give us the answer as negative 3. So that question mark was a negative 3. Log 1/2 of 8 is negative 3. Next, we need to know how to find the inverse. It'll give you an example, and it'll say maybe find the inverse of y equals 6 to the x power. When I look at that, I'm going to see, okay, it wants me to find the inverse of this type of equation, but it's actually backwards. Like I'm looking at it backwards, which is pretty annoying. So I'm just going to flip it around first to make it easier on myself. And I'm going to write 6 to the x equals y, just so it looks like what I have right here. Can't write an x correctly. Six to the x equals y. I'm just flipping it around so it's easier to look at. Now, whenever you find the inverse, you're going to switch the x and the y. So I'm going to write 6 to the y equals x. Now I'm going to write that as a logarithm. Log base 6, remember this becomes the base. Log base 6 of x equals y. So this is the inverse of this. Another example of finding the inverse, it says y equals natural log x plus 3. I have to see, this one's actually in this form. It's not in exponent form, so we're going to have to do the conversion in this way to change it to this exponent form to find the inverse. First thing I'm going to do is look at it and just say it's backwards. I'm used to seeing the log, in this case natural log, on the left, so I'm just going to write it as that. Natural log x plus 3 equals y. You know natural log has a base of e, and so I'm going to rewrite this as e. Oh, sorry. Before we do that, we have to switch x and y. If we don't do that, we cannot find the inverse. So we're going to write natural log, which has a base of e, y plus 3 equals x. Now we're going to write it as an exponent, e to the x equals y plus 3. All I did was switch this exactly as we've been doing this whole video. This becomes here. This moves over to the exponent, and the y plus 3 moves to the other side. Now to finish this off, I'm just going to subtract 3, solving for y. So the inverse is e to the x minus 3 equals the inverse. These two are inverse functions. The last thing you have to do is graph. So let's say it wants you to graph y equals log 3 of x. You can't use the calculator to graph this. Like I said, it only understands log base 10 and natural log. So you need to change this to a form you can graph. So we're just going to rewrite that. Of course, I'm going to flip it around first because it's easier to look at. Log base 3x equals y. 3 to the y equals x. And then we're just going to plug in some points. So when I plug in 0 for y, I get 3 to the 0, that equals 1. When I plug in 1 for y, I get 3 to the first power equals 3. When I plug in 2 for y, I get 3 to the second power, which is 9. Smaller than 0, and see what we get, just so you can see what these graphs look like. So let's plug in something like y equals negative 1. So 3 to the negative 1 is actually 1/3. Let's plug in an even smaller number. So let's say negative 3. So 3 to the negative 3, if you plug that in a calculator, or you know to flip that 3 over, is actually 0.037. So what you're going to notice is it's going to get really, really close to x equals 0, but it's never actually going to touch x equals 0. So let's put in negative 10. So we'll do 3 to the negative 10, and we get 0.00005. So it'll never actually touch 0. So x equals 0 is the asymptote for these types of functions. So we'll plug in our points. 1, 0, 3. Oh, sorry, I plugged that in incorrectly. So we get 1, 0. We get 3, 1, 9, 2, negative, or 1/3, negative 1, 0.07, negative 3. So it's going to look like this. And like I said before, you have to graph this yourself because the calculator can't do it for you.